Hi everyone, welcome back to Workshop and part 3 of the Wavetek 1281 multimeter repair. Now in the last video, the part 2 video, you saw me testing out the original relays for the unit that were supposedly or suspected faulty, and I also compared them to the operation of the Panasonic ones that were fitted. So I'll link those videos down below. Now off camera I did actually test the contact resistance of all the original relays. I wanted to see if not only were any of them faulty, but were any of them showing any signs of being arced across the contacts that might have increased the contact resistance. And I did a 4-wire test on my 6.5 digit multimeter, and I got anywhere between 10 and 17 milliohms across all the relays, the S2 relays being slightly lower than the S4 ones. Now the datasheet for those original relays says a maximum contact resistance of 50 milliohms, so we're actually well within spec. And what that says is there was nothing wrong with all the original relays. So in this video I'm going to delve a bit deeper now. I'm actually going to remove this top board here, this analog board, and I'm actually going to have a look at the underside, because as I said in the part 1 video, the owner had said there was some burnt tracks and they'd gone ahead and done some repairs on that. So I want to actually take a look at that and make any necessary mods or fixes that I feel are necessary before we start probing the circuit board with the scope and trying to find out why the multimeter is not changing ranges properly. So let's get this board out. Now, as it's an 8.5 digit multimeter and metrology grade, it's actually quite necessary to put on the nitrile gloves, especially as I'll be handling the analog board. Some nice tight fitting nitrile gloves, so I don't actually feel that I'm actually wearing them. Right, so here we go. The board has obviously been out before by the owner in order to make those repairs, so it should be pretty easy to get it out. There are some little plugs scattered around the board which I just need to lift up. They weren't actually pushed back down into place to secure the board, so it should be more or less ready to come out. And I'll lift it from this side first, I think, because there's a little bit of a gap. Just push those connectors out of the way down the side there where there's a gap. And this one here out the way. I think it should lift up. There we go. And there's the board, safely removed from the unit. And yes, I would suggest, is that the repairs that have been made there? Not too sure. So let me move the meter out of the way and get this on the workbench. Looking at the back of the board, these white wires would appear to be the repairs that have been made to those burnt out tracks. You can see behind this one here, looking up here, there's a burnt track there, scorched off of the board. You can see the burn mark there, and the previous owners just linked it out. But I'm going to check those just to make sure they are properly in place. In fact, I might replace them because the soldered connections at the ends don't look that healthy, and I prefer to redo them. Now, if there's any high current tracks, I will need to keep a heavier gauge wire on there, but for some of them like this one here, I can just go back to Kynar wire there, I think, because it's just a simple, small, thin trace linking, looks like two of the relays there. Now there is some other things I've noticed on the board. Let's take a look. Looking over at the other side of the board, looks like we've got some rework done here. There's some flux residue there, and look at that, we've got a small piece of solder or perhaps a pin or something like that, so we'll need to clean that off. And there's more of the same across other parts of the board as well. Look at that, we've got a small solder splash there that looks like it's almost shorting out a couple of those pins there on that IC. So yeah, I think the whole of the back of the board needs a bit of a clean up. So I've got a couple of dark spots up here. That's actually the back of the board where there's a couple of plus and minus 15 volt regulators on small heat sinks. So yeah, that's no real problem. That's just over time the board has just darkened a bit with the heat. Now there is one other curious thing with the back of this board. Let me zoom in on a section and I'll show you what I mean. Now this is all over the board, but if you look at this here, if you look closely, look at this here, you've got two lines running down there and another one running down here. Well, I was a bit curious about what that was, because that's where the solder mask has not been laid. And I thought to myself, why is that? And if you look at the other side of the board, there's two tracks in this case here that run side by side down there on the other side of the board, the top side, where the solder mask has purposely not been laid over the track. Much like this one here, there's no solder mask over the top of that track, and they've done that intentionally. And it looks like wherever there's been top side tracks that have had a requirement to leave the tinning exposed, they've removed the solder mask on the top side. However, that removal process has gone right through the bottom side. So when you look all over this board, there are these weird lines, and there's another one running along here and down here like that. And it turns out it's not going to cause a problem with the board at all, obviously, but it's just a peculiar after effect of the PCB processes at the time of removing solder mask on one side. Looks like it had to bleed over onto the second side. The other thing I've noticed is where these relays have been fitted, for instance this one up here, there's plenty of flux still in place, so I'll need to remove all that flux. That's no good on an 8.5 digit multimeter. And also spotted around the board, there are solder joints like this where they look a little bit lacking in solder, so I will need to touch them up. Okay, so that's that first jumper off. So the first thing I'm going to do is I'm going to replace that wire with some Kynar. It's just a thin track, and I'm going to use my favourite Kynar wire wrapping wire. And there's the first one in place. Now I'm not going to stick it down with any liquid solder mask or anything like that. I don't want the solder mask or whatever I apply to affect the resistances between any of the existing tracks or anything like that. So I've got no choice really but just to leave it in place like that, roughly following the existing route of that track. I'll try and straighten it out a little bit more and try and make it follow, because this wire is bendable to a certain degree, but that's what I'm going to do. Well, I've gone ahead and removed the white wires over this side of the board, and none of the burnt out tracks are on this bottom side, so I'm assuming the burnt out tracks must be from the other side of the board. And you can see one of them down there, you can see the track coming along there, and it's broken there, and then it continues on again. I'm not going to put a jumper on the bottom side. I think I can get in about there and repair that track where the brake is, and then I should have a good contact from end to end. Now I'm actually going to go ahead and do this off camera because I need to get my head right over here, and I won't be able to film that, and I'll try and make all the necessary repairs on this side of the board. And I think maybe actually there's another burnt track there, and that must be one of the other ones. Right, I've gone ahead and removed this connector here just to take a look on the underside, and wow, you can see the scorch marks there, as those tracks there all burnt out, not looking good at all. And the connector itself a little bit worse for wear. You can see the scorch marks on the underside. So I think I should have a replacement for this. We'll go ahead and replace this connector, but I'll need to tidy up these scorch marks first and try and do some repairs. I don't really want to put tracks on the underside, jumpers on the underside, so I'm going to try and see if I can fix these tracks on the top side. Let's clean up the board. Now to repair these tracks, like I said earlier, I'm not going to do it on the bottom side, I'm actually going to do it on the top side. However, as you'll notice, some of the tracks have been broken or burnt off right at the connector itself. However, the beauty of the Kynar wire that I use is that I can actually put it down through the hole, flatten it off, and solder it up after I scrape some of that solder mask off, and repair it on the top side. Then it just means that I can push the connector down alongside the Kynar wire, because there is actually enough room, and solder it on the bottom side. So I'll go ahead and do that now. Like I said earlier, I need to get my head right over this to be able to do that, and I'll come back. Now there's one track on the connector which I don't think I need to actually do anything with, and that's this one here, and it looks like it comes along and connects to that pad there. In actual fact, I don't think it did. I think that's actually a guard trace. There's a little telltale sign here where it looks like there was a small T at the end of that track without actually connecting to that pad. Because if you follow it round there, hopefully you can see that. There's just right down in there, you can see, let me see if I can get my little torch on it. You can see the end of the T at the other end, so it doesn't actually connect to nothing. And that via there just connects down onto the underside of the board where there's a continuation of that same track. And in actual fact, on the other side of the board, it comes along exactly like this and tees in exactly the same place. So nothing to do there. So I think my new connector is ready to go onto the board. There it is, pressed into place, fully seated on the board with the Kynar wire down through two of the holes. So I'll solder up on the other side now. Now one thing that does concern me, and that is during the replacement of these relays, these Panasonic relays that have been fitted here by the owner, has the owner inadvertently ripped out the through-hole plating on some of those relay pads, and that would certainly cause an issue with point-to-point traces on the board. And only one way to find that out, and that is to actually remove the relay and actually check the pads. But I'm not going to do that yet. I'm going to take a look over the board on the other side, tidy up some of the solder joints that I spotted, and then I'm going to power it up again and let's see if there's any difference. Right, let's get the board fitted back in and give it a bash. Right, let's power it up. We're in DCV mode at the moment, so I'm just going to immediately go over to ohms mode because it was shorted out here before. and it's exactly the same again. So no change there. So let me put in my PDVS2 Mini, set it to 1 volt, and let's see if we get anything on DCV. Nope, no difference whatsoever. So the same fault. So I think now I'm going to start probing on the top side. Okay, I thought I'd start probing the relay drive on the analog board. And the first thing I did obviously is check the supplies. The plus 5 volts and the plus and minus 15 volts from those two regulators, they're working okay. No problem there. The digital ICs on the analog board are getting proper power. So I just thought I'd probe the relay circuit, or part of it, that I know is working. And that is the function switching on the front of the unit. I can press the DCV button, then the AC button, ohms, DCI, ACI, and they all appear to be switching the relays. I'm not sure if you can hear that in the background. You can hear the various relays switching. So I'll just go through them again. No problem. So let's just scope one of those signals and familiarise ourselves with one of them. So let's just go on to this pin 18 here, the one that is driving the front low relay. Right, I'll just press one of the function buttons. And there you see it's gone from a high impedance state, pulsed low, then back high impedance again. So that's it driving those latched relays. And if I just go along the different functions in the front of the meter, and there we go, there's another one, high impedance, and then it goes high. So the high and the low correspond to setting and resetting that latched relay. So that drive and that one anyway is working fine. Now these relays here are all to do with the input switching, because this unit has the front terminals obviously, but it also has a channel A and channel B inputs at the back. So you can see front high, front low, channel A high, channel A low, channel B high, channel B low. So I'm looking in the wrong place at the moment. Now there are a couple of schematics, or sheets of the schematics, that we need to look at. The first one is the input signal switching. You've got the front panel assembly bananas coming in here, and then you've got a channel A and a channel B coming in here, because on the rear of the unit there is actually rear unit inputs, two sets, a channel A and a channel B, and you can see the high, the I plus, the I minus low, etc. down there. And those all come together via these relays, which switch them in and out depending on what set of inputs you're using, and then go off to either the current assembly board. You can see the I plus and I minus there, ohms board here, the high and the low, and the AC assembly board here. So I want to make sure, because we're getting nothing changing on the display at all, the first thing I want to make sure is that the signals are being routed correctly. Now in terms of DC voltage, they obviously don't go to any one of these three boards. They actually come further down on this bus here onto another sheet. So I'll bring that up now. So here is the continuation of that sheet. You can see from sheet 1 there, you've got the high, and you've got a bunch of other signals here as well. So the high is what I want to be looking at. Let's just probe randomly on one of these components here, and let's see if the signal's getting this far. I found this link here, LKJ. So I need to find that on the component layout, and we should be able to probe on there to see if we're getting a signal via the front panel bananas if I've selected them and in DCV mode. And there is LKJ there, right on this resistor here, 3.3 meg resistor, so I should be able to scope that pretty easy. And first things first, I'm actually going to scope the input signal as it comes into this board from the high connector, the high banana. So I've got on the scope there, I've got my PDVS2 Mini set to 0 volts, so I'll just ramp it up, and you can see that's going up, no problem whatsoever, and back down again. And I've got the meter in DCV mode. So now let's go over to LKJ and see what we're getting. I'm at 0 volts again. Let me just ramp that up, and I'm not getting anything. Nothing at all. So let's go back to the schematic. Right, so there is the high signal, more or less at the point I was measuring it on that second schematic sheet, albeit after a relay. So if I follow that up, it's all the way up here, along here, and down there from the high input banana. So if I can, I want to scope after this relay here, RL106, the front low. But before I do that, let me just check the input selection on the meter itself. There's a button called input there, and it gives me a choice of front, channel A, channel B, and a bunch of others. So I should hear relays clicking when I change from front to channel A to B, etc. So it's on front at the moment. Let me go to channel A. No switching at all, no relays at all. B, so I'm not getting any relay switching at all for that front input selection. And there in fact is RL106 right at the top there, one of the relays or the circuits that we was looking at previously. So let's just see if the drive to that relay is working. So I've got the scope in pin 15, which is the output of that IC. So let me just change from front panel to channel A, and you can see it goes low there, and back to front panel. Not exactly sure why it's not latching like some of the other ones are. This one seems to be driven on permanently. So let's go on to pin 5, which is the output of that IC. 1, 2, 3, 4, 5, and do the same again on the front panel. I'm on the front right now, so let's go to channel A, no change there. Channel B, back to front panel. I'm not getting anything at all. No change whatsoever. Now that chip does have an enable line, pin 1, so let's take a look at it. And this is a 15 volt IC. So the 0 volts is down there, and the 15 volts is on that halfway line. And it's not in this state anyway. Pulled up to 15 volts, that enable line. So let me just select channel A or channel B. Look at that, I'm getting a small pulse. But it's not going all the way down. I wonder if that's the problem. We've got an enable line problem on that IC. And there's the enable line there. It's got a pull up resistor plus 15 volts. If you follow it all the way down, right down here and away along here, it comes from sheet 7, the update-L from sheet 7, and there it is there, update-L. And yep, you can see we've got an NPN transistor. Remember, we've got a pull-up resistor on this line, and there we go. There's Q701 and its neighbour Q702. Right, looking at the collector of that 2N3904, not really seeing 15 volts, but the transistor could be partially switched on. So let's take a look at the base, and it's at 0 volts. So should be seeing 15 volts on that collector. So there's that update signal there. It should say update-H, going away off to that series resistor, and follow it back, and it comes from M802 and through a 1K resistor network by the looks of it, with a 100K down to ground. So if I scope pin 11, let's see what that's doing. So there's IC there. So 9, 10, there's pin 11 there. Let's take a look at the scope. And if I change the inputs, front panel, channel A, yep, we're getting something. Short pulse there, yep. So that pin 11 should be going through the 1K resistor array there and away off to the series resistor near that transistor. Okay, so I'm going to check out this pin 11 on that IC there. I should be seeing 1K over to one side of this resistor. Yep, 1K, and on the other side, because it's in series, I should be getting 5.7 because it's a 4.7K resistor, and I do. So the connection from that pin 11 across to that resistor there is okay. So we are getting a low pulsing high signal coming in here. Now because the output of this 4538 appears to be low all the time, we'll assume that's normal. If there's no error signal coming in, then we've effectively got a voltage divider, 4.75K on both, onto the base of both of those transistors. And with a 5 volt signal coming in here, you've got more than enough voltage or current to drive those transistors on. Let's look at the collector of the other transistor, because these should both be doing exactly the same thing, just with different voltage levels. Because this one here has got a pull-up resistor. Is that plus 35 volts, I think? Yep, that's why there's two transistors, because this one's got a pull-up resistor of plus 15. So there we go, I'm on the collector of Q702. Let me just change the front panel input selection again. Yep, every now and then it goes low as I press a button. So that's working just fine. But the collector of the other transistor is not working. It's got that weird voltage on it. So either that transistor's not switching properly, or the update-L signal here is being pulled by a faulty IC. Could be either one of these two ICs, or maybe R808, this 15.6 or 15.0 resistor here, is not pulling up properly. I suspect one of the ICs. So to test the transistor in circuit, let's do a diode test. It's an NPN transistor, so the positive on the base. So the emitter first, I should get a diode, yep, 0.6, and the collector, yep, I get diode as well. Now I can't locate R808, that enable line pull-up resistor, because the component layout's out of date and that resistor's not on the board. However, if I go across the enable line, which is pin 1, and the supply, the 15 volts with the power off, I'm getting 15K. So yes, it is indeed a 15K resistor, and it's okay. And of course I did check the 15 volts is okay as well. I've gone ahead and sketched up the enable signal, including that monostable, that 4538, that's driven from a signal called R-L. So I'm thinking that's an error signal. Maybe the meter's gone into some sort of error mode. And also the drive for the actual enable signal itself. Now in normal operation, which I appear to have right now, this signal coming out of the 4538 is low all the time. Now as we've seen, the 3106 outputs a short pulse through this voltage divider series resistor into the base of the transistor, which when it goes high, it turns on this transistor and pulls that enable line low. Now of course, because the 4538 signal output is low all the time, you've effectively got a voltage divider there as well, but there's still more than enough current to drive that transistor on all the time when it pulses high. However, you would think at first look that the error signal coming in here would be designed to stop the transistor turning on in order to keep the enable line high, but it doesn't work like that. Irrespective of what's happening here, there's more than enough current when this 4538 goes high to turn on that transistor. So whenever the 4538 is high, we will have an enable. And that seems counterintuitive at first look. However, without digging any deeper, what I think's going on is The error signal wants to drive the enable low all the time and keep it low for as long as the output of the 4538 is high. It then gives the processor time to drive every single relay into the unlatched position in one fell swoop. Now that's pure theory. There's probably more to it than that, because we do actually have the error signal coming into 3106. Can't find any data on that actual IC, so I'm not exactly sure what it is. And of course, I haven't been able to see the error signal in operation to verify any of this. But it's just an idea. So either that transistor is faulty despite it measuring okay on my meter, or this IC here is faulty and it's doing something weird with that enable line. So I'll order up a couple of those ICs and just double check I've got sockets as well, and I'll put those two ICs in sockets and we'll give it a test. And here is the replacement ICs, the 40244s. I couldn't find them from the usual sources, DigiKey, RS, Farnell and etc. But I did manage to find them on eBay, which is always a bit hit or miss. But looking at these ones, they do look brand new. The legs are still splayed apart like they do when you buy them new, and if you look closely at the actual legs themselves, there's no wear marks where they would have been marked up when they're inserted into sockets, which is normally the case. So looks like they're brand new. So next thing to do is take the board out the 1281 again, and let's get to work replacing the two existing ones. Right, pull the ICs from the board. One. Come on, out you come. And two. And a quick check of the pins on the old ICs I've just removed, just to make sure there's no through-hole plating stuck on the pins, which would cause a problem resoldering the new ones in place, and they're all perfect. Let's solder the sockets in place. That's the sockets in. I'll clean up the board after I know it's working, because I still have to clean up the rest of this board like I mentioned at the start of the video, but I'll do that later on once I get it up and running. Right, ready to put them on the board, making sure I get them the right way round. That's the first one in. And the second one in. Now I notice on these old ICs they're date coded 1988. Wow, that's quite a while ago. So hopefully they're both okay. So now we'll go ahead and fit the PCB back into the unit and we're ready for a power up. And what we're looking for, I'm going to go to the input there and just change the input from the front to channel A to channel B, and we're looking for clicking on those relays. So let's have a look and see what we can hear. Yes! Yes! I'm getting clicking. So that was it. One of those 40224s wasn't working. Now I did just change out both of them just because, but I can hear the relays clicking. So I'll set it to front and we'll go to ohms. Now previously that was just reading short circuit like it is there. So let's have a look. Error overload. That's looking good. Let's go to DCV. Haha, looking good. Let me get a PDVS2 Mini hooked up and let's see if it's actually working. Right. Plug that in there. Plug that in there. We'll go to the 1 volt range and let's give it 1 volt and see what happens. Yes! It's working! Look at that! 0.999995 volts for a 1 volt input. It's actually quite accurate as well. So let's try some of the other ranges. How about the 10 volt range? Should lose a DP. Yes, that's working. 100 volt. And 1000 volt. Yes! Okay, back to the 1 volt. And let's go down on the PDVS2 Mini to 100 millivolts. And we'll go to the 100 millivolt range. Yes! 99.9963. It's working. So let me try ohms mode. Now I do actually have a homemade resistor box here with some nice low ppm per degree C resistors. So let's try, I'm not going to bother hooking up 4 wire, so let's try a 1k resistor to start with. In here. Oh, ohms. And yes! Let's go to the 1k range. Yep, 1.000437. Let's try something a bit further up this range. Let's try the 100k. And the 100k range there. Yep, resistance is working. And I've got my current source hooked up out of shot. And I've got it set to 1 milliamp. It's not particularly accurate when I first switch it on. But you can see I'm getting 0.99 of a milliamp, so it's looking good. So let me try some of the other ranges. So I'll put the current down and we'll try that 100 microamp range. Yep, that seems fine. 96 microamps. And we'll try going the other way now. So 9.99 I've set it to. Yep. And the 100 milliamp range. Yep, 9.99. And the 1 amp range. Yep, 0.01. Close enough. So I've tested ACV and ACI off camera. They seem to be working. A quick test, mind you. I didn't film that because I had to turn the meter around to do that, to get it hooked up to my Kikasui PCR 500M, but it appears to be working fine. And I'm back to 1 volt DC and everything seems great. Now I don't know much about using this meter, some of the other functions, etc., especially the calibration and that sort of modes that you can go into, or the config. I don't know nothing about them and I'm not really going to get into them. My remit was to make a repair and it looks like I've done that. So the next thing to do, so I need to remove the board again and get some IPA on it and start cleaning up some of that flux off the back of the board. Then I can plug it back in for the last time. Well, that's the covers on and I've left it for a couple of hours just under test there, just to make sure the stability is okay, and it is. I'm getting 0.999995 volts for a 1 volt input from the PDVS2 Mini, and it seems to be rock solid, so no problems at all. So what was wrong? Well, ultimately it was at 40224 IC, but whether anything else was wrong, i.e. those links that were a little bit dodgy that I replaced on the underside and the top side, who knows, there could have been other contributing factors there, but as I showed in the video, I just replaced everything and made it as good as I can be. My only regret is I don't have a big enough ultrasonic tank to actually clean the board properly. I would have liked to have done that, but my ultrasonic cleaner is just not big enough, so I had to resort to just doing it with the brush and the IPA. So I can send the unit back to its owner and hopefully it will make some good use of it. So thanks for watching, and remember you can always comment down below, and don't forget to like and subscribe. It really does help the channel grow. There's plenty more repair videos on my channel, from the simple to the complex. Check them out, and thanks for watching.